Hello everyone, and welcome. Today we're diving into an exciting topic, predictive versus generative AI. On this first slide, you'll see the title of our presentation. We'll explore what makes these two types of AI distinct, how they work, and their applications. So let's get started and discover the fascinating world of artificial intelligence together. Predictive AI is a fascinating area of machine learning that focuses on training models to make predictions or decisions based on data. Essentially, we give the model a set of input data, and it learns to recognize patterns within that data. These patterns then enable the model to make accurate predictions when it encounters new, unseen inputs. This ability to generalize from past data to future situations is what makes predictive AI so powerful. You'll find predictive AI being used in many everyday applications, such as image recognition, where it helps identify objects in photos, speech recognition, like voice assistants understanding spoken commands, and natural language processing, which allows computers to understand and generate human language. Connecting this back to our overall theme, predictive AI is a core component of how machines can learn from data and make smarter, more informed decisions, something that's transforming industries and improving our daily lives. Now, let's take a closer look at the differences between predictive AI and generative AI. Predictive AI is all about making accurate predictions based on labeled data. It can help us solve many problems like detecting fraud, diagnosing medical conditions, or predicting customer churn. Its strength lies in analyzing past data to forecast future outcomes. On the other hand, generative AI is designed to create new, often creative content. It can generate art, music, or even written work, opening up exciting possibilities in creative industries. However, generative models can sometimes produce biased or inappropriate content if the input data isn't carefully managed. When it comes to limitations, predictive AI depends heavily on the quality and quantity of labeled data available. If the data is limited or biased, the predictions may be less accurate. It also may struggle to make predictions outside of its trained data, which can be a challenge for unexpected scenarios. Generative AI, meanwhile, can sometimes produce content that lacks coherence or doesn't fully understand the context, especially if the input data is lacking. Additionally, both types of AI require significant computational resources for training and deployment, but generative AI might not always be suitable for applications that demand high accuracy and precision. Ultimately, both predictive and generative AI serve different purposes, but understanding their strengths and limitations helps us choose the right tool for the right problem as we explore the broader potential of AI. Now let's take a closer look at the stages of the data lifecycle. First up is data collection. This is where data is gathered from a variety of sources like sensors, surveys, and even online platforms. It's the foundation. Without good data collection, everything downstream is affected. Next, we have data storage. Once we've collected the data, it needs to be stored securely to protect it from loss or unauthorized access. Security is crucial here, especially when dealing with sensitive information. Then comes data processing. This is where we analyze the data to find insights and patterns. Techniques like machine learning algorithms play a big role here, helping us turn raw data into meaningful information. After processing, we move to data use. At this stage, the insights gained are applied to make decisions or inform policies. Essentially, this is where the value of the data is realized. Sometimes, it's necessary to share data with other organizations or individuals. This data sharing can foster collaboration and innovation, but it must be done responsibly to maintain privacy and security. Data retention is also an important part of the life cycle. It refers to how long we keep the data, balancing the need for future use with privacy considerations. Finally, when data is no longer needed, it must be disposed of securely. This could mean deleting digital files properly or destroying physical media, ensuring that sensitive information doesn't fall into the wrong hands. Understanding these stages helps us see the full picture of responsible data management, especially as we explore its role in AI and decision-making. Now, let's take a look at 4 key data protection laws and regulations that are shaping how organizations handle data and AI. First, we have the California Consumer Privacy Act, or CCPA. This set of regulations applies specifically to companies that do business in California and collect personal data from California residents. It emphasizes consumer rights, like knowing what data is collected and having control over it. Next, there's the Health Insurance Portability and Accountability Act, or HIPAA. This law is focused on healthcare organizations across the United States. It governs how protected health information, your medical records and personal health data, can be used and disclosed, ensuring patient privacy is maintained. Then, we have the General Data Protection Regulation, or GDPR. This is a comprehensive regulation that applies to any company processing the personal data of European Union citizens. Its scope is broad, emphasizing transparency, data minimization, and giving individuals control over their personal information. Finally, there's the European Union's Artificial Intelligence Act, often called the EU AI Act. This regulation is quite groundbreaking because it specifically targets AI systems. It bans those with unacceptable risks and sets strict legal requirements for high-risk AI applications, aiming to ensure safety and accountability. All these frameworks are part of a broader legal and regulatory landscape for data and AI. They highlight how important it is for organizations to understand and comply with different regional laws. This is essential not only for legal compliance, but also for building trust with users and customers in a global digital environment. Effective data lifecycle management requires a range of best practices to ensure that data is collected, stored, and used in a responsible and ethical way. Some of these best practices include implementing data governance policies and procedures. This helps ensure that data is handled responsibly and ethically throughout its life cycle. It's also crucial to conduct regular audits and assessments. These help identify any weaknesses or vulnerabilities that could compromise the data or its security. Ensuring that the data is accurate, complete, and representative of the target population is another key point. This way, decisions based on the data are reliable and valid. Storing data securely is essential, and access should only be granted to authorized users. This minimizes the risk of unauthorized use or breaches. It's equally important to ensure that data is used only for its intended purpose. Sharing data responsibly and ethically is part of maintaining trust and compliance. Placing appropriate safeguards to protect the data at every stage is vital. And finally, having clear data retention policies is necessary. Once data is no longer needed, it should be securely deleted to prevent unnecessary risks. All these practices together help us manage the data lifecycle effectively, aligning with our overall theme of responsible data use. Thank you so much for your time and attention today. I truly appreciate your engagement and interest in what we've discussed. Remember, the key takeaways are the importance of understanding the core concepts and how they connect to the bigger picture. I hope this presentation has provided you with valuable insights to apply in your own work. Again, thank you for being here, and I look forward to any questions or discussions you might have.